Is it working? We'll see in a second. Sweet. It's working. Hey, everybody. Thanks for joining on this slightly offset presentation day. I'm going to be running through creating your own drivers on Zephyr. I've also included in the description box so the driver that I will be showing here. It's actually a driver for the HPMA 115S0, which is a PM2.5 sensor. So that is one driver I actually had to kind of create from scratch using this guy, or using my air quality wing board here. And I'm going to shut that off. And it's using UART, and that's just one thing that had to get integrated into the driver, and then using the sensor API, actually pulling that data and using it inside the application. So let's get going. I'm just going to take a quick drink. And if you haven't already, subscribe, because that helps me figure out what you guys want to see. So if you like this content, give it a thumbs up. That'd be awesome. Now, moving on. Let's jump into it. So I'm going to be focusing primarily on using the sensor API. And what's going to happen is your drivers, as far as what Zephyr makes it really flexible for you to put drivers or your application code wherever. So you could actually put some drivers within your application code. In this example, I'm going to be using an external module. So something to keep in mind, but you can also just package them together, especially if they're very tightly integrated, and there's not really any use or reason to make an external module. In this case, I did make it external for anybody else that might want to use the drivers. In this case, multiple drivers in the same module, so we'll see that in a second. And let me see. And then you use what you need, and then what you don't, it doesn't get compiled in, so you don't have to worry about it. And if you haven't already checked out my previous last week's presentation on drivers, go ahead and check that out, because that'll be a good primer for kind of understanding how drivers are organized. But we'll go into more of that today. So what we'll be reviewing quickly is the use of the, not only can you use a West manifest to pull subdependencies for your main project, but you can also use it to pull dependencies for a module, which is awesome. You can also, what's very important for defining any type of module is the use of creating a Zephyr folder, and within it called Module.yaml. And this will basically help define or tell Zephyr where to find what, if you have like kconfig or cmake lists or even device tree bindings, it'll basically say, hey, I have a kconfig. Hey, I have a cmake list. Hey, I have a device tree binding folder, so on and so forth. There's also some other things you can use it for, but those are like the three main important things, especially when we're coming to drivers. And then what I've done, and you'll see a little bit later, is that I've organized those guys into a drivers folder, and then they're all kind of separated out per the different drivers. So first off is West. So this is the West YAML for this exact project. If you go into the description box there, this is the exact same source that I'm sharing. And what I've done here is I'm pulling some, not particularly for the HPMA, but this is actually for an SGP driver. And I've pulled their code from their repository, mostly because I didn't really want to redo what they already had done. They don't have, Sensorion does not have a Zephyr specific driver, especially one that uses the sensor API. So I'm pulling some extra bits there. I think it had to do with I forget exactly, but you can always go in there and look yourself. But this allows you to integrate anything that is Zephyr compatible or isn't Zephyr compatible. I've often done this with like the QCBOR library. I'm using West.yaml to actually pull in those dependencies. Again, that project is not very Zephyr friendly, so You might have to do some extra finagling to get it to work, but in this case, I think I actually did some strategic changes in a local CMake that allow it to pull these files from this embedded -sgp.git repository. So something to keep in mind. I already hit that first point, but again, the West.yaml, you can use it for your modules and your top level projects. The important thing here is to use the import :true. And what this does is, if you don't use this, it only pulls the top level dependency. So if you go to the next slide, you'll see, for example, in the app for the air quality wing, I'm pulling in the NRF SDK. If I didn't have that import :true, that would only pull NRF directory and it wouldn't pull all its sub dependencies. So you need that import :true. So important to have, and just something to bear in mind if you're going to be integrating any type of drivers that do have dependencies. So here is moving on, here's the module.yaml. And basically you're saying, hey, for building, the CMake is here. Kconfig actually could be a dot, or for instance, either of those, CMake or kconfigs, they could be custom names. So you might see in some modules, like the NRF module, if you're using Nordic stuff, the kconfig file is called kconfig.nrf, I believe. So something to keep in mind. And then under settings, the important part here is, because we are basically creating new drivers that have to have a device binding that you can use in overlays and actually device tree entries in general, you will need to set the DTS root. In this case, the DTS root, when you're doing a dot, is just a DTS folder /bindings. So anything lives in that DTS /bindings, or if you're on Windows, /, and that will be the place that Zephyr will look for the bindings. So just something, without any of these definitions, your code may not compile or might not find the source. So very important to have at least all those CMake, kconfig, and if you have any device bindings, make sure those are in there as well. And we just covered that. Oh, on a roll here. And then what we're going to do is look at the device tree bindings. So this is the part where you're actually connecting the device tree and your code together. So you're creating the device tree entry that can be put into an overlay. That overlay basically defines, hey, we have this device that's attached to UART1 or I2C1. So we're going to be creating that device tree overlay, which then allows us to put it, or the device tree binding, which allows us to do that. And I'll show you what that looks like. So here is the device tree binding for the HPMA 115S0, and it follows. It's just a simple UART device. The only thing I did that I added here, and you'll see in a second, that I added this properties tab, and this allows you to pull in different things. In this case, I'm pulling in an array of GPIOs. So on my device, I can enable or disable, and in the driver, it actually enables and disables the device itself. The power to it, at least. So you can look at, you can see that it's important to have it in the DTS bindings folder. This is critical, or else it won't find it. Again, very important. These conventions are very important, unless you set in your module.yaml a different place, a different location. So something to keep in mind. And then we'll look at the file name kind of has this convention, and you'll see why in a second, why it's important. But typically manufacturer, comma, and then like the part number. And then, as you saw before, the properties allow you to define different functionality, GPIOs, or even setting different functions. I know on the LS212 DHTR, whatever it is, the accelerometer on the NRF 9160 Feather, there is an option there to basically turn off the pull up on the SDO pin, the address select pin. So that is, I kind of mentioned this in the previous presentation, but that's like the fine line between the kconfig and the kind of device tree. is like, where do I put this? Do I put it in the overlay because it's more hardware related, or do I put it in the kconfig? So in this case, that functionality was in the device tree bindings. So, and that is, if you're writing drivers, it's completely up to you. I'm sure Zephyr Maximus might have a more strict way of thinking about it, but that's kind of the line you have to tread there. And then here's the usage of it. So you can see we got a label there, the HPMA 115S0. It's compatible with, and then if you see that, the Honeywell, comma, and then the part name, that's actually the same prefix to the file name of the device tree entry. So those need to match in order to kind of pull it out. Typically, there is some type of label. I think this is actually deprecating, but it's still required. And then you can see that I'm actually using, so if there's no definition of the enable -GPIOs, it won't be used. But if it does exist, then you'll have to put an entry in there. So I'm using GPIO, the port 0, and then I'm using pin 1. And you can actually set the active polarity. So for instance, if you want it to be active, you can set it active or deactive. And we're basically saying when it's active, it's going to be high. So in the code, you can say, I want it to be active, and depending on what you've actually set in the device tree, in the overlay there, yeah, it'll either be low or high. So it's a nice little thing, another added abstraction that's useful. So again, if you don't have that enabled GPIO, the code's not going to look for it, and that's all built into the code for the driver itself, so that's something that you control. If you don't write anything that has to do with the enabled GPIOs, then it's not going to use it. So again, you look at that compatible line, it's the same as name as the DTS, and then you can see the usage of that optional enabled -GPIOs. And then in terms of folder organization, here's kind of like what it looks like. You got that kconfig, and then you got that CMake list. Those are pretty normal and standard. And then all the action really happens in the driver files, in that .c and .h, and it uses the sensor API. So, and we'll just dive into what it looks like a little bit here. And then if you guys have questions, we could always dive in a little bit more around the specifics. So you can see the first thing here is that HPMA 115S0-_init, and this is where everything gets initialized. We're getting the device tree binding, which actually needs to be updated with the macro, but you can also see I'm setting up that UART driver, and I'm setting up a callback to receive any data when data is received. Very handy, because without it doesn't work. And then this function actually gets initialized through the macro, like the initialization macro. So when Zephyr starts up, if you have a driver, this function will actually get called before any of your application code gets called. So if you look down here, you can see the device defined, and then you got the name, and then you got the label, and then you got that HPMI init. So that guy gets called at the sensor init priority. So it'll get initialized post kernel, along with all the other sensor init devices. So along that priority, and you can see that HPMA 115S0 API. That is all we're basically tying the function calls for the sensor API to calls that are within this HPMA 115S0.c file. And you'll see right here, so I've defined a sample fetch and a channel get. So the sample fetch functions for the sensor APIs will get the data and then save it in memory, essentially. So later on you can get it, and that's what the channel get is. You're getting the data from the driver that's already been read. So we're not reading and getting at the same time, or those are two separate functions. And this is like the very, very basic of the sensor driver API of just getting some data and then fetching it. There's attribute sets and attribute gets and things like that, which allow you to talk back and forth with the driver in a more abstracted way. And that should be it. So that is very quick and dirty 20-minute introduction to creating your own driver in Zephyr. Of course, if you have any questions, feel free to let me know. And I hope everybody's had a fantastic holiday season, and hope all you guys have a very safe New Year. And let me see if there's any questions in the chat. I don't think so. But if you do, feel free to leave a comment and I'll get back to you. And you can also send me a message and check out my website in the description box below. Do have some limited NRF9160 feathers back in stock. So if anybody's interested in one of those are there because DigiKey is almost out. All right, well, if you guys have any other questions or actually any other suggestions or things that you want to see covered in Zephyr, please let me know. Let me see, we do have one question here. So why some drivers need to be configured in a project configuration? Mohammed, I'm not really sure what you mean here, but I'll try to answer. A project configuration. So you're probably referring to the prj.conf, and that's something I kind of touched on in the last video, and essentially, let me jump to that. So without defining what, let me jump to that guy. So let's look at this prj.conf right here, and I'll show you what's going on exactly. So you need to not only connect it within your overlay, because that sets up the hardware, but you can set up an overlay, but you can also disable the driver so it doesn't load in your application. So if you look here, and let me see if I can make it bigger so it's not so small. Get rid of that. You can see the sensors in the project configuration here. We're turning on the biggest thing for the HPMA 115S0 is you got to turn on serial here, and then you have to make sure the sensor API is also turned on. And the biggest thing for actually using the driver itself is this config underscore HPMA 115S0. And this is like the conditional compilation variable that allows Zephyr to actually go to the source and compile that source. Without that, or if it's marked as equals n, you're not going to be able to use the driver. It's not going to be able to find it. So it'll be very obvious because you'll be calling that sensor API, and it's just going to be like, we don't know anything about HPMA 115S0. So think of the project.conf, the prj.conf as the kind of the control, as like if you want it turned on or turned off. And then the device tree bindings and the overlay stuff as like, here's my hardware, here's what I have, and here's what I can use, but it might not be turned on or turned off. It's just, here's what's available. And you have to do that, especially if you have a board, maybe it's a device if you have connected externally to the board. It's something you have to add in your overlay. So hope that helps. Hey Chip, is there a good Zephyr 101 book site? Online course, topics like this may make more sense with context. Yes, I completely agree. This is one of the main reasons why I've been doing these videos, is that hopefully we can turn it into something more comprehensive, or over time we can start sharing more and more about Zephyr ecosystem, because this is like me like 2 years in of using Zephyr, and it wasn't very straightforward to begin with, for sure. But now, as I've been using it, it's like, wow, like this makes life a lot easier. Especially there's a lot of functionality, drivers. It's all like batteries included. And even so, like for instance, I'm keeping these driver modules externally, or as a module that you can pull into your project. You can just search GitHub for HPMA 115S0 drivers, and you can pull it into your project like that, even if it's not part of the Zephyr main tree. So. What I would say, what exists right now is I do have some blog articles on my site, just kind of talking about some of the usage of the NRF9160, and also You can check out the documentation on NRF9160, docs.jaredwolf.com. I know you've already been there, but other people might not. And then also the Zephyr documentation is not bad. It actually is pretty comprehensive. It's just very scary. Because there's a lot of like weird abstracted RTOS-y things that are just like, what is this? And it's different coming from a world where all those things were already taken care of for you, because Particle, it is free RTOS and it has a lot of the same constructs and the same ideas, except a lot of those things are hidden from you, so you don't really understand how they work. So sometimes it's just, you gotta, in order to make a project work, sometimes you have to understand the underlying functionality, and that Zephyr documentation does a pretty good job. Sometimes I feel like there's certain examples or certain concepts that are missing, and that's why I'm trying to cover them in these videos, because it is a little overwhelming. So, but if there's something that you would like to see, please let me know, because I will definitely do a video for you. Not a problem. Or you're like, send me an email and I can turn it into a video or something, or even just reply to your email. It's fine. Let's see, Mohammed, thanks. Yeah, no problem. Hope that helped. So I will give it a second here and make sure there's no other questions before I sign off. Gotta get back to restoring Bort NRF9160 boards in my layer. Let me see if there's anything else. Dun, dun, dun. I don't think so. No questions? Cool. Hey, Franz. Good to see you here. All right. Well, I hope you guys have a really great week. And thanks, Chip. Awesome, that helped. Hope you have an awesome week. And I will talk to you soon.